we want to pay close attention because our exit ticket is going to have one problem with consecutive integers and one problem with laws of exponents, the division portion of it. So that's what's on it today. So first thing it says in number 1 is find 3 consecutive odd integers. Now, as soon as I see that, I'm going to write those 3 expressions for those. So odd or even, it doesn't matter. The first one's going to be an x. The second one is going to be an x plus 2. The third one is going to be an x plus 4. And it says there's 3 of them. So I wrote 3 of them. Okay? Don't forget, if it's just consecutive, that's x, x plus 1, x plus 2. Because remember, consecutive, they just go up by 1s. Odds and evens go up by 2s. Okay? So now let's see what it says. It says such that the sum of the first and the third. First, third. The sum of the first and the third equals the sum of the second and 43. The sum of the second one and 43. How many people wrote that correctly? 3 people. 4 people. Okay? Now it's just a multi-step equation problem. The first thing I'm going to do is combine like terms on the left. 1x and 1x is 2x. I'm going to combine like terms on the right. I got a 2 and a 43. That gives me a 45. So that's x plus 45. I need to get my variables on the same side. So I'm going to subtract 1x. Folks, we might want to be writing this down if we didn't. 2x minus 1x is just a 1x. And I'm going to bring everything down. And now I have a one-step equation. I'm going to subtract 4 on both sides, and I get x equals 41. It says find the 3. So 41 is x. And what do I do to get to my next one? And I'm going to keep adding 2. So add 2 and you get 43. Add 2 more, you get 45. So those are your 3 consecutive odd integers. Question on that? Okay? Y'all, this one begins differently. This begins like the original consecutive integers that we did. It says the sum of 3 consecutive odd integers. It's telling you right there to add up all 3. The sum of 3 is. So we've got an x added to an x plus 2 added to an x plus 4. The sum of 3 consecutive odd integers. Sum is telling you to add them up. Is an equal sign. 18 less than, and remember less than is a subtraction. It's also a turnaround phrase, so the 18 goes in the back. Might want to remember this for the exit ticket. Less than is a subtraction sign. It's also a turnaround phrase, so the 18 goes in the back. And what goes in the front is 5 times the middle number. There's the middle number. It's 5 times the middle number. So that's the setup. I'm going to do 2 steps on one line. I'm going to combine like terms here. So I've got a 1x, a 1x, and a 1x. That's a 3x. I'm going to combine a 2 and a 4 to get 6. Bring down the equal sign. I'm going to go ahead and distribute. When I distribute, I get 5x plus 10. I'm going to bring down my minus 18. Now I can combine like terms here. 10 minus 18 is negative 8. I'm going to bring everything else down. Now I've got to get variables on the same side. So I'm going to subtract 5x on both sides. 3x minus 5x is a negative 2x. I'm going to bring everything else down. Bring down the positive 6. Bring down the negative 8. It's a two-step equation now. So I'm going to subtract 6 on both sides. Bring down the negative 2x. The equal sign, when I combine on the right side, I get negative 14. Last step is to divide both sides by negative 2. I get x equals 7. So the first integer is 7. And to get to the next one, I add 2. So I've got 7, 9, and 11. Question on that. Okay. And last one, this is what we learned about yesterday. We are dividing like bases, so we divide the coefficients. What do we do with the powers? We subtract the powers. So 45 divided by 9 is 5. X to the 8th divided by x to the 7th. When I subtract that, I get x to the first power. And what happens to the y's? It's 5x. Good? Okay, now, y'all, this is what your Delta Math is on. It's going to be quick. Some of y'all are going to finish this in minutes, but before y'all get on it, I need y'all to stop, flip over, flip this over, flip this over. I just want to remind you of something. Let's wait before we open up our Chromebooks, folks. Go ahead and write this down. Go ahead and write that down. 20, a to the 4th, b to the 10th, divided by 5, a to the 11th, b to the 7th. Okay. We did this yesterday, and you guys had no problem with it. Most of you wrote something like this. 20 divided by 5 is 4. And then when you subtracted here, you got 7 and you got a negative 7. And then when you subtracted here, you got b to the 3rd. Okay? Y'all, that is not wrong, but it is not completely simplified. So what I was telling you is see, we can't have negative powers. So what I was telling you is since the power is bigger on the bottom, when you do your subtraction, you just move that variable to the bottom and you keep a positive power on it. Okay? So when you subtract, you get a 7, but since it's bigger on the bottom, it's just a to the 7th on the bottom. The 4 is still on top, and the b to the 3rd is still on top. This is completely simplified. This is not. Okay? Question on that? Okie dokie. So we're going to do some Delta Math for probably about 20 minutes, okay? We always want to be doing power to a power first. This is not 3 times 2. This is 3 squared. That's 9. The A, we're multiplying powers. 4 times 2 is 8. On the B, 3 times 2 is 6. Okay, now we're going to bring down the little monomial that we didn't mess with. Now we are multiplying coefficients, so that gives me a 45, and we are adding powers. So on the A, that would be to the 9th power, and on the B, that would be to the 9th power. How many people got that right? Okay. We good? Okay. What are we supposed to be doing first? Okay, you should be doing this first. Now y'all listen to me. So you're ignoring this, you're doing that first. Okay, when you do that, then you're going to ignore the bottom. And you're going to do that. Oh. Okay. Okay, so you're ignoring these and you're doing that first. Okay, then you're ignoring the bottom and you're taking that second step. Then the bottom comes in and you're doing your division. It's 3 parts. First part, second part, third part. Got to start here. All right, folks. We always need to do the power to a power first. 2 raised to the third power is 8. The x will be to the 9th. The y will be to the 12th. Okay, and now I'm going to bring down the 3xy to the 5th. Yes, I mean it's still a bottom part even though we're not going to do it yet. Okay, so now I need to do the top. I am multiplying coefficients, so that's 24. I am adding powers on top, so that's 9 plus 1 is 10. And then on the y, 12 plus 5 is 17. Okay, now I'm going to go ahead and put my division in there. And now the third step, I'm dividing, and I get 4. X is bigger on the top. When I subtract, I get 8. Y is bigger on the top. When I subtract, I get 5. Question? Okay. All right, let's do one more. Actually, hang on a second. All right. What are we doing first? Power to a power. So, we got to do the power to a power first. So, -5 squared. Remember, just a side note, y'all, you want to put your negative numbers in a parenthesis all by themselves before you square them or cube them or whatever, and then it won't lie to you. This is a positive 25, not a negative. And then when I distribute powers, your C would be squared, your D would be to the 8th power. Now I'm going to bring down everything that I did not mess with. Okay, now I'm going to do the top. I'm multiplying coefficients. That gives me 50. I'm adding powers. So C to the 5th, D to the 9th on top. Okay, now I'm going to pop that little denominator in there. Now I'm dividing. So I divide coefficients and I get 5. I subtract powers, so that's C to the 4th. D is bigger on the bottom, so when I do my subtraction, I need D on the bottom. We good there? Okay, now, got a question for you. Are these different problems? Raise your hand if you say yes, these are going to be different problems. These are not the same, not going to get the same answer. I've got 1, 2, 3, 4, 5, 6, 7 that say these are different problems. Does anybody think it's the same problem?
That's me.
William thinks it's the same problem. Okay, so, William, you're incorrect. Okay, so folks, this is definitely a part of this. Y'all, if you'll notice this square here, these parentheses are coming all the way down. That square pertains to the numerator and the denominator. Here, if you'll notice, the parenthesis does not come all the way down. The square does not pertain to the bottom. Okay? So here, you are literally going to be applying the square to the top and to the bottom. Here, you're only applying the square to the top. So go ahead and try both of those. Go ahead and try both of those, okay? Okay, so with this first one, y'all, because of the way the parenthesis is, the square is going to apply to the top and to the bottom. So 4 squared on top is 16. I multiply powers and get a to the 6. 5 squared on the bottom is 25. I multiply powers and get b to the 8th. Y'all, there's nothing else I can do. 16 over 25 does not reduce, and there's an a on top and a b on the bottom. This is all I can do. Okay, here, the square only applies to the numerator, so I have 16, a to the 6th, and then 5b to the 4th is just the way it stands, and it cannot be reduced. Notice, y'all, these are not the same answers. Y'all good? Okay.